Hey guys, I want to share the latest with you on our exploration of planets beyond the solar system. So, a team of collaborators and I made a weather map of a planet called WASP-43b. This is an amazing planet. It's twice as massive as Jupiter, and yet it orbits so close to its host star that it takes less than 24 hours to go all the way around. We watched this in action. We used the Hubble Space Telescope to observe 3 complete revolutions of the planet around the star, and we used the data to make a map of the planet's entire atmosphere. So I'm going to tell you a little bit about how we did it and what we learned. Alright, so here's a little animation showing the star plus planet system. The star is the big yellow circle in the middle, and the planet's off to the left. You can see the day side of the planet is shown in orange. It's because it's very hot. It's being continuously blasted by very intense radiation from the host star. Keep an eye on the bottom to see how the brightness changes with time as the planet orbits. Here we go. The planet's going to cross in front of the star and block some of the light. Then as it rotates around, you see more of that bright day side. The brightness is increasing, increasing, increasing until the planet is eclipsed by the star. There's a dip again, and then the day side rotates out of view. So we'll watch this one more time. You can see how the planet is blocking light from the star during the transit. Then it gets brighter as more of the day side becomes visible as the planet orbits around. Then again the drop in brightness because of the eclipse. And then gradual dimming as the day side rotates out of view. Here's our real data for WASP-43b. You can see the eclipse in the middle and the transit inset in the upper right. And there's a huge amount we can learn about the planet by studying the shape of this light curve. One trick that we do is we compare the brightness of the star and the planet to the brightness of the star alone when the planet is being eclipsed. And so if you take star plus planet and you subtract the star, what you're left with is light from just the planet. We used this technique to study the light shining from WASP-43b, and we discovered that there's water vapor in the planet's atmosphere. And this confirms the idea we had from our own solar system that water is a really important building block for forming planets. In addition to this, we also studied variation in the planet's brightness over the course of its orbit, and we used this to make a map of its temperature. Here it is. You can see the day side of the planet is wickedly hot. It's almost 3,000 degrees Fahrenheit. And as you move away from the day side, the temperature just drops like a rock. This planet is totally different from anything we have in our own solar system. And it's a real testament to the tremendous power of the Hubble Space Telescope that we can make a map like this for a planet that's hundreds of light years away. Of course, we'd like to make similar measurements for Earth-like planets, and currently that's out of reach, even for Hubble. But fortunately, NASA's building a successor to Hubble called James Webb. These are just 6 of the 18 mirrors that are going to go on James Webb. It will have 7 times the light gathering power that Hubble has. And we hope to use James Webb to study the climate and the atmospheric chemistry and the potential habitability of a few of the many Earth-like planets we know exist in the Milky Way. But until then, I owe a really big thank you to the entire team who worked on the project, in particular Kevin Stevenson, who made the awesome temperature map of the planet. Thanks, guys.